I'd like to show you what would happen if one of the responses was incorrectly coded. So as you learned in an earlier video, you can enter these data points manually, but the problem or the risk is entering something incorrectly. So let's take our traffic chaos delay reason number 1 as an example. Let's say that the researcher who put in this data inadvertently put 11 instead of 1, which is a very common mistake to make. And in this case, it's the first row, quite easy to catch. But imagine if you have data sets with hundreds or thousands even of responses, it'd be very easy to overlook this 11 amongst all the other numbers in the data set. So it's an easy fix. What you'll do is you go analyze, descriptive statistics, and frequencies. And we have our traffic chaos variable in the variables box. If not, just bring it over. And we are going to hit OK. So this is just assuming we want to get some information on the mean, median, and mode. So actually, we'll go back in. We'll make sure those are selected. Mean, median, mode, sum, minimum, and maximum. And hit continue. And we can leave all the other information the same. So hit OK. And something interesting will happen. So we have 120 responses. Our mean has actually gone up from the previous video. So if you go back to where we looked at mean, median, and mode for traffic chaos, the mean was smaller than what it is here. So the problem with the outlier is it's overrepresented the average, the arithmetic mean of our data set. It makes it seem like there were more delay reasons than actually indicated. Here's the check you can do. So first, you can either look in the statistics box. We know that we're looking at Likert scale data between 1 and 7. However, if you look here, our maximum is 11. This is a clear indication that something is wrong in our data set. Going down to our traffic chaos frequency table, we can confirm that we have an extra single 11 somewhere in our data. The problem is we don't know where that is. So one solution could be sorting the data set and doing that in descending order. That would indicate it. But this is an easy example. Sometimes you'll have multiple incorrectly input data points. So what do you do in that case? So here is the best solution in SPSS. You'll go to Analyze, Descriptive Statistics, and you'll choose the option called Explore. So here we have a box that gives us an option, a window that has boxes with options that we can bring data in, and it will tell us where those outliers are. But first we have to tell it that that's what we want. So let's click on Traffic Chaos and bring it over to the dependent list. And then I want you to go to Statistics, keep descriptive selected at a 95% confidence interval, but also select this option here, Outliers. So SPSS will automatically scrape the data in your data set, and it will identify any data that doesn't match with the others in the set. Next, click on Plots, and I'd like you to choose Factor Levels Together using Stem and Leaf. And then hit Continue, and keep this displayed both, and press OK. So here we can see a summary of our Explore analysis. We have an N of 120. Everything looks right here. If we look at the descriptives box, we can see that they've also provided some statistics here. We'll look at these later on, but we can clearly see that that 11 is still hanging around. The best visual way to look at this is through both the extreme values box and the stem and the box plot, which I'll show you coming up. So the extreme values box will show you which value is highest, which value is lowest. And in this case, our highest value is our first case number at 11. So this is a really good indication that we can now identify or locate that case number and correct the value that's in that spot. So we would go back to our survey and find case number 1 and input the correct number based on what they actually responded. This is valuable to do it this way because, as I said earlier, you may have multiple extreme values. You might have another high one. You might have 3, 4, 5. You might have low values where you have potentially negative numbers or some other wonky things that happen in SPSS data entry procedures. So this is a great check to make sure that everything else fits within our expected range of 1 to 7, which these numbers do. And here's a nice visual way to look at this. So this is called a box plot. The box plot specifies the highest value, the median, the upper average, the lower average, and the lowest number. So here we can see right up here, this 1 with the star. The star indicates that we have one outlier in our data set. So this is a valuable way to view very quickly and see that one response in our data set fits outside of the norm. All you need to do is, again, double check your survey. We find that we typed in correctly, so we would actually put this as 1. We rerun our analysis. We can explore again the same way, and we'll see here that now that outlier has disappeared and our box plot correctly identifies 1 as our lowest point and 7 as our highest point, with our median and our higher and upper lower averages indicated here.